Hello everyone, this is the third lecture of the data science series using Python. In this lecture, the topic are exploratory data analysis. In the exploratory data analysis, first topic is how to construct a bar graph with overlay using Python. Let's start. A bar graph with overlay is a visual tool to compare the categorical data with the another layer of information, such as trend line or additional categories. Bars represent categorical variables while the overlay, example, line or point, add context such as the numerical trends or the comparison matrix. For instance, overlaying a line on a bar chart could show average values or a cumulative percentage, enabling easy visual analysis of a pattern and trends. This method is valuable for presenting multi-dimensional relationship in a single chart. Let's see the example of the bar graph with overlay. These are the example of the bar graph with overlay using metapolyme and seaborn. First of all, import the metapolyme.pilot as PLT, import seaborn as SNS, import pandas as PD. These are the data of a category, count and type, and these are the plot bar with the overlay using seaborn. Let's see the output of this one. These are the output of this code bar graph with the overlay. Next, the topic is how to construct a contingency table using Python. Contingency tables summarize the relationship between the two categorical variables in a matrix format. Each cell shows the frequency or proportion of the observation for a specific category combination. For example, a table might show the count of males and females across different ages group. These tables are the foundational for the statistical tests such as the chi-square to assess the independence of the variable. They are widely used for the quick insight into a categorical data distribution and relationship. Let's see the example of this. These are the contingency table. First of all, import pandas as the PD. These are the data. These are the method df equal to pd.data frame, and the parameter are the data. Let's see the example. Output of this code. The output of the code are this contingency table, category, field pass table, etc. So the next topic is how to construct a histogram with the overlay using Python. Histogram displays the distribution of the continuous variable using bins to group value. Adding an overlay such as density curves or another histogram enriches the visualization. For example, overlaying a normal distribution curves help assess whether the data align with the theoretical expectation. This technique aids in understanding the shape, spread, and the central tendency of the data while facilitating comparison. The next is the how to perform binding based on the predictive value using Python. Binding divides a continuous variable into the intervals or bins based on its relationship with the target variables. Predictive binding ensures that each binds provide meaningful insights into the target, such as the grouping income level based on their influence on a loan default probability. It simplifies complex relationship and improves the model interpretability while the preserving predictive power. Binding is crucial for the handling skewed data and enhancing algorithm like a decision tree. Let's see the example of this code. These are the histogram with the overlay. First of all, import the metapolyme pilot as PLT, C1 as SNS, and pandas as PD. These are the data and the output. output of this code are here. Histogram with the overlay and the binding .py, performing binding based on the predictive value using pandas. First, the import pandas as pg and the numpy as np. The data are in the form of scores, and the method are called df equal to pd.data frame, and the parameter are the data. This is the output of this code: scores, score pins, etc.